Independent Study Project. Reach for the top scoreboard. The goal of this ISP is to replace the buzzer systems used for Quiz Bowl type games used by Royal St. George's College. The new system will feature a scoreboard for both individual players and a team, wireless interactions between the players and the game master, and peripheral locking. In this stage of the multi-stage ISP, a scoreboard was built using a printed circuit board, 7-segment displays, and shift registers. It's using random variables to simulate a game. The microcontroller running this simulation is the ATmega 2560 or Arduino Mega development board. This board features much more storage space for code and variable information, as well as several more input-output pins than the Arduino Uno or Nano. The board is located behind the PCB underneath a prototyping shield. From here, it's able to supply the signals for the latch pins, data pins, clock pin, and master reset pins for the shift registers on the scoreboard. These pins help control the display that appears on the 7-segment display systems. We'll call a 7-segment display system any pair of 7-segment displays powered by shift registers that are linked together. On the full Eagle schematic, there are a total of 14 of these 7-segment display systems. On the board, 7 of these systems are designated to each team, with 6 of them representing individual players and 1 representing the total score. The surface area of this board is about 8 by 12 inches and uses only through-hole technology components. Given the power requirements for this project, power should be sourced from an external 5-volt source rather than from the Arduino, as this would cause damage to the many voltage output pins. The external source of voltage can be used as an input source of voltage for the Arduino. This is only a temporary solution until the next stage of this project. For the random variable-based simulation, the code is initialized by defining a bunch of arrays which contain the scores for each team and the 7-segment display hex arrays for the bit shift register outputs. The setup section begins by setting each 7-segment display output to be a 0. It also sets all the scores to 0. For the next stage, it will be able to reach EEPROM to restore old scores. The loop section begins by retrieving random variables to indicate the team and the player of that team who scores a point. For that player, the system taps into the shift register system associated with that player and increments the value shown by 1. Then, the total score displays are updated for each team. This is done by adding up all the variables within the score arrays for each team and then storing them in another variable which is then shifted out. Now, even though the shift registers are linked together for each system, they can still only shift out 8-bit values. So the values have to be shifted out twice, once for the 1s digit and the 10s digit. To do this, a value can be divided by 10, and that new value can be stored to a new variable, and then the value can be divided by 10 again, and the remainder can be stored to a different variable. These variables can then be shifted out independently. The next steps for this project are to implement an HID control panel for the game master, and then create the peripherals for each player and enable the wireless communication between them. I hope to complete most, if not all of this, by early March of 2024. Thank you for listening.